First, we'll take production of ammonia by the Haber process. That's the topic. Production of ammonia by the Haber process. Haber process. The name of the process is also important because there are various ways of producing ammonia. And before talking about the Haber process, so we'll take a few minutes to discuss what we are going to do in this particular unit. So we have discussed chemical kinetics and chemical equilibrium under physical chemistry. There are some more. And then here we are going to discuss how the theories we have learned up to now are applied in industries, right? Applied in industries, right? Then what's the main purpose of an industry? Money. In any industry, the main purpose is money, right? Economy, right? Economical factor, financial things, right? Therefore, so we have to think about how maximum product is obtained within very short period of time, right? The time is money, right? As far as the industry is concerned, the time is money, right? Okay. If we take longer time, then it costs a lot. Okay. Is that clear? As far as the industry is concerned, right? Yeah. Therefore, we have to plan any industry such a way to produce certain amount of the product within the minimum period of time, shortest period of time, right? That is, kinetic factors come to the picture. Okay. Then we produce the maximum product means if the reaction is equilibrium, so point of equilibrium should be very much close to the product side. Can you understand? That's how the theories come to the picture. KPKC theories come to the picture. Okay, is that clear? Now, most of the chemical reactions are reversible reactions, right? That's why those two units we learn are very important as far as chemical industries are concerned. Okay, right? Yeah. Today we are going to discuss production of ammonia by the Haber process. Then first of all, we have to think about what the raw materials are. Right. The reaction that we are going to use is nitrogen react with hydrogen to give you ammonia. You know, this reaction is a reversible reaction, right? Ammonia gas. This way. Right. Then what has to be the raw material? Nitrogen gas and hydrogen gas. Right. How to produce nitrogen gas? How to supply nitrogen gas to the industry? Right. You know, 78% of nitrogen by volume is there in atmosphere. Right. So we can easily take nitrogen from atmosphere. How? First, you have to liquefy air by compressing, and then liquid air should be separated. Now, the techniques still being discussed by the fractional distillation. So we'll discuss later, right? Yeah. Anyway, then you can just mention nitrogen is taken from air by fractional distillation of the liquid air. Okay. Then at the same time, oxygen also produced, then oxygen can be used for some other purpose, right? Then how to produce hydrogen? Hydrogen is generated as a byproduct in the petroleum industry. So we can take it from there, or there are various ways. You can just read it and understand, right? There are various ways of producing hydrogen for the industry. Now, here we are talking about the industry, right? Then you don't say hydrogen can be produced by the reaction between sulfuric and magnesium. That cannot be used for the industry because it's very costly, right? Production of sulfuric, production of magnesium, even very highly cost, right? Therefore, so always you have to think of, so we are doing an industry, right? So I told you what the main purpose of an industry, right? Always you have to keep that thing in your mind. That's how these reactions differ from the reaction what we carry out in the laboratories. Okay, right. So you can find out. You can read the resource book and find out the various ways. I told you one major one. Major one is to take hydrogen produced as a byproduct in the petroleum industry. Okay, right. Then we can mix these two together and allow to react. You know, nitrogen is not that reactive. So then how can you make this reaction happen? Yes. Yeah. So we have to supply energy. We have to supply energy. The amount of energy that should be supplied can be reduced by introducing catalyst. Catalyst, right? Why? Catalysts provide you an alternative path with a relatively lower activation energy, right? So we have to supply energy to overcome the activation energy barrier, right? If we can provide an alternative path with a relatively small activation energy barrier, then the amount of energy that should be supplied can be minimized. Okay, then we can cut the cost. Okay, right. So in this case, iron is the catalyst used in this industry. Iron, and right. To get the maximum use of this iron, yeah, what type of catalysis reaction is taking place? Heterogeneous catalysis, right? So we use a specific word for this type of catalysis where the reactants are gases and the catalyst is a solid. Yes. Adsorption, very good. Adsorption. Adsorption. That means these reactant particles are adsorbed onto the surface of the catalyst, right? Therefore, we have to maximize the surface area of the catalyst. How can you do it? You can use the powder. You can use iron powder, right? In the industry, what is used is that is called iron bed. Say there are like mesh and put iron powder, right? And allow these gases to move with those across these iron beds, right? Then the adsorption is perfect. Is that clear? Then you can increase the efficiency of the catalytic action. Okay, right. Iron base. Right. Then this reaction is exothermic. Delta H is negative. Delta H is negative. Okay. Then I told you that our purpose is to get the maximum product at the same time within a very short period of time. Okay, right. Then to get the maximum product, we have to shift this point of equilibrium as much as to the right hand side. Okay, right. then what are the steps that can be taken to shift the point of equilibrium towards the product side? Yeah. Since the forward reaction is exothermic, to promote the forward reaction, you can decrease the temperature. You can decrease the temperature. That's correct. Okay, is that clear? Right. So you have to cool the system. But when you cool the system, then there's a problem in kindly factors. You know, when the temperature is very low, the rate of the reaction is very low. Right? That means you get large amount. You get the maximum product, but you have to wait for a long time. Okay, is that clear? Right. Now there are two factors in opposing direction. To get the maximum product, you have to increase the temperature. Right? But when you increase the temperature, the point of equilibrium shifts this way. So then you don't get the maximum product. Right? Wait, I made a mistake. To get the maximum product, to get the maximum product, you have to cool the system. You have to cool the system, right? That means you have to decrease the temperature. When you decrease the temperature, you have to wait for a long time to get that extra product, right? Then no point of waiting a longer time because it's costly, right? Because now we are doing this as an industry, right? Okay. Therefore, there are two things in opposite directions. Two things in opposite direction. Okay. Then we have to do several trials and see under what conditions you get the maximum benefit for the industry. Right? That is called the optimal conditions. Optimal conditions. The word we use in that type of situation is the optimal. That means we do several trials and find out what the best condition to get the maximum profit, not the maximum product, maximum profit. Is that clear? Right. That has been found as around 450 Celsius. Around 450 Celsius. That is not that very high temperature, but not a very low temperature, right? Moderate temperature, okay? Right. Then, how can you promote the forward reaction? By setting the pressure. What about the pressure? Right. Now you can see, as far as the forward reaction is concerned, it associates with the decrease in the number of gaseous particles. 3 plus 1 is 4, 8 is 2, right? Therefore, high pressure will promote the forward reaction. Therefore, you have to increase the pressure. It's no problem. How can you increase the pressure? In practice or in industry? In industry. Now, have you seen when you use, say, nitrogen gas to your vehicle tire, or even when you pump gas, vehicle tire of a vehicle, what's the phenomenon behind that? How they generate pressure? There's a gadget called compression to generate pressure. So you have to supply electrical energy to work that, right? That means energy, right? To generate high pressure, energy is consumed. Okay, that is cost. Okay, right. So generating high pressure is a cost. Then if the pressure is high, then what about the reaction vessel or the reaction chamber or the tubes that carry that high gases at very high pressure? So you have to make the system to withstand that high pressure. Okay, that also cost. Is that clear? Right. Therefore, somewhat or the moderate high pressure around 250 atm, 250 times the atmospheric pressure. In industry, we don't consider this as very high pressure. In industry, 250 times the atmospheric pressure, right? So atmospheric pressure also very high. That's very high. Even in this classroom, so we have very high pressure, right? So when you open this door, so this door also open automatically. Most of the time, unless you close it properly, right? Because of the air pressure, right? Okay, right. Anyway, this 250 atm. Is that clear? Now these are the optimal conditions. Optimal conditions. Okay, right. Now there are some minor points. Are these clear? Then I will give you questions. Right? I will give you questions. Then almost same type of questions will be given for the A-level paper as well. Because the question that can be given is very, very limited. Right? That's right. Okay. Therefore, the question that I'm going to give you, maybe they are in the paper if it is given under this particular industry. Okay, right. Definitely. Most of the questions, right? Then here it is very important to introduce these two gases in the proper molar ratio, 1:3. Right. There's a possibility of promoting forward reaction by increasing the concentration of the reactant. That's obvious, no? Right? But introducing the gases in the proper ratio 1:3 is important. Why? You know, we use the heterogeneous catalysis where the adsorption takes place, right? Then what happens is, if you introduce these two in 1:1 ratio, say nitrogen is cheaper than hydrogen, right? So in the purpose of promoting the forward reaction, you can use excess of nitrogen because when nitrogen concentration is high, the forward reaction can be promoted. Okay. Then if you use 1:1 ratio, these two, what happens is you need 1:3 ratio for the reaction to take place. Right? That means you have excess of nitrogen. Right? Then the nitrogen will adsorb onto the surface than what is needed. Okay? That means you can't get the maximum use of the catalyst. Some of nitrogen is adsorbed but not participate for the reaction. Why? There are no hydrogen. There are no hydrogen to react because hydrogen has to be 3 times the nitrogen. Okay, is that clear? Yeah. In that way, you may not use the entire surface of the catalyst for the reaction. Is that clear? Right. Therefore, it's very important to introduce the gases, reaction gases in the correct molar ratio. Is that clear? Right. The other thing is it has to be very pure without dust. Why? If dust is there, if dust particles can adsorb onto the surface, not adsorption, but can disturb the adsorption process of this. That's obvious, no? Right? If surface of the catalyst is covered by dust, then adsorption is disturbed, right? Therefore, it's very important to use very clear reactant gases in the very clear form, right? Okay, right. Then the other very important point. Now, since this is a reversible reaction, you don't get ammonia only as the product. Ammonia only as the product. You get a mixture of gases, nitrogen, hydrogen, and nitrogen. Nitrogen, hydrogen, and ammonia. Mixture of three gases, right? Now, under inorganic chemistry, now we have done many analyses when there are many chemical components, solid components, mixture of cations, mixture of anions. Then we know how to analyze. But we have never discussed how to separate gases from a mixture of gases. That is very easy. Right. Then the term critical temperature comes to the picture. Critical temperature. What is the critical temperature? Now, this unit can be taken as like a revision of the entire syllabus, right? Revision, like a revision. Okay. Critical temperature. What's the critical temperature? Maximum temperature that a gas can be liquefied by compressing, right? Right. Out of these three, which has the highest critical temperature out of these three? Ammonia. Stronger the interactions, higher the critical temperature, right? Now you have these three, nitrogen, hydrogen, and ammonia as a mixture, right? Then you are going to compress. But the problem is it is already compressed 250 times the atmospheric pressure, right? Then no need to compress again. But still, these are in the form of gases, why the temperature is high, right? Therefore, what we have to do is drop the temperature. Then the pressure is enough to make ammonia a liquid first, while other two are still remaining as gases. Right? Critical temperatures of these two are higher, slower than that of ammonia. Right? That means at the temperature, ammonia get liquefied. These two are remain in the gaseous phase as gases. Is that clear? Okay, right. Now what you do is we drop the temperature, right? And there's a very simple technique to drop the temperature. Why? Now this is a compressed gas. Compressed gas. Compressed gas, yes? Increase the volume. When you increase the volume, what happens? Temperature? How? How do you know? Huh? What's the theory you learn in physics? Sorry? Right. What do you call that effect? Huh? Joule-Thomson? No. Right. That's correct. That's correct. Yeah. I didn't think. I didn't know that you talk about this thing in your physics, right? That's very good, right? Yeah, that's yeah. So we'll take a simple thing that say you have a balloon, you have blown very large volume, right? Right? Then, if you release it, what do you observe? You just release, right? Low to very large volume and then just release. Then what do you observe? Yeah, it run here and there like this, right? And once it drop down, when you take it, what do you see? What do you see? What do you see? When you drop down, what do you see? When you take it and observe, what do you see? What do you see? Yes. Something coming out like water. Even you use a pump. Cutting pin work you feel like it's but if you use a pump, then do you get that water droplets? Yes, yes. But it's entirely not killer. Yeah, what happens is inside the balloon, the pressure is higher than the atmospheric pressure. That means you have compressed air, right? You have compressed air. The theory is very simple. I don't think that it is explaining even in physics. The theory is this. It's a compressed gas, right? When you increase the volume, what happens is the average distance between two particles, increases. That means say before increasing the volume, say the particles were this distance, right? And then this particular particle move from here to here, this one from here to here, right? Then what about the force? In most of the cases, the net attractive force is created, right? That means these particles are in attraction together, right? Therefore, these particles, these two particles, this particular particle move along the attractive force. Sorry, opposite to the attractive force. Right? The attractive force is in this direction. Okay? But the motion is from here to here, opposite to the force. Is that clear? It's like attraction on this pen towards this. If I lift this one up, it's opposite to the attractive force, right? In this case, I have to supply energy. Endothermic process. When endothermic process takes place, temperature decrease. That's what happens. It is not explained in chemistry. What about in physics? Is it explained? I don't think that in this in detail, right? Anyway, it's very simple. Should be included in syllabus. My point is very simple and very nice. And that's what happened even in your LP gas cylinder. Liquid petroleum, it's highly compressed. When you take gas from your household LP gas cylinder, right? If you take it continuously, temperature should drop. It should cool, right? Okay. අනිත් දවස් අම්ම පත්තු වෙනකොට බොක බදාගෙන ඉන්න බං කියලා. You will feel cool, right? අපට ගිලේ නැත්නම් මම කොහරි ගින්දායි මේ fish පදේ වගේ. Okay, right. Then anyway, these gases, this gas mixture highly compressed, right? So you allow certain amount of pressure to drop, then at the same time that temperature pressure to release, then at the same time pressure also drop, then you get only ammonia liquefied. So nitrogen and hydrogen remain in the gaseous phase, so easily be separated, and this can be reused for the industry back, right? Okay, is that clear? Right. I think now you can keep something in your mind. So you try to answer these questions without looking at the book. So you can do it. So I'm going to give you the questions. Then to do, so you have to write at least today or even at least tomorrow. Otherwise you can't. Right? Then write down these questions. What are the raw materials? What are the raw materials? And explain how those raw materials are supplied. Next one. Write the balanced chemical equation. Write the balanced chemical equation. Explain steps. Explain steps that can be taken. Explain steps that can be taken to maximize the amount of ammonia. Maximize the amount of ammonia that can be produced from a given amount of reactants. Theoretically. Explain how above steps you mentioned are applied in the Haber process. Giving reasons. Right. Is that the questions? So you can write two questions at the same time if you want. So you can take temperature factor first, and you can write what has to be the theoretically how the temperature should be adjusted and how it is applied in the industry. What's the reason? And then take the pressure like that. Okay, is that clear? Right. Then next question. Name the catalyst. Name the catalyst. And explain how important use of a catalyst in industry. Then now once you are given a question, then you should be able to think how many points should be how many points should be tested, right? Here there are two main points. Can you see? Two main points. One point is the rate factor, other point is the energy factor. Is that clear? Energy factor and the rate factor, right? Both come to the cost. Okay, is that clear? Right. So you have to explain, keeping that thing in your mind, right? Okay, right. Next one. Introducing the reactant gases. Introducing reactant gases into the reaction chamber. Into the reaction chamber. In free of dust. In free of dust. And in the proper molar ratio. And in the proper molar ratio is very important. Explain. Right. Next one. Define the critical temperature. Explain how ammonia be separated from a mixture of gases in the equilibrium mixture of gases in the above equilibrium mixture based on critical temperature. Based on critical temperature. Right. The last question. Write a list of uses of ammonia. What's the main use? What's the main use? Fertilize, making fertilize. Do we produce ammonia in Sri Lanka? So we consider Sri Lanka as an agricultural country, so but don't produce a molecule of them. Right. Anyway, then you can think of environmental possible environmental pollution as well by this industry. So we'll discuss this thing at the end of this unit. This means unit 14, right? Okay, right, that's it. Okay, is that clear? This has to be the way, right? So if I give you a knot, it has to be what is same in the resource code, right? Now you have to write your creative answer. Okay, so you can read the book, no problem. So you'll be given questions, almost the same questions in the exam, right? Okay, now we have time to just start titration, carbonate, HCl titration. Yeah, so you can go back to our lesson. Write the topic. So you have to keep a separate book for industrial chemistry, right? Separate book, right?